Hello and welcome to my presentation of design development for Rescuer's food heating device, providing warm food to hypothermic casualties. The research stage started with looking at the brand, extracting key principles, ideas and DNA. These included a forward-looking responsible ideology, rugged and functional DNA, and large bulky styling. Moving on to secondary research, we looked at food types and storage possibilities. We concluded a highly calorific vegetarian soup vacuum sealed would provide the most appropriate food component for rescue services, since it would provide energy to counteract hypothermia, be edible for most people and last the longest when stored. We also looked at existing products and technologies to inspire that part of the design, and we carried out some user research with mountain rescue teams and search and rescue service personnel. The main insights gained from these were that teams carry a lot of heavy equipment, so would want something lightweight and portable. They purchase their own equipment, so something relatively cheap would be preferable. It should be able to be used in all environments and conditions, and be easy and quick to repair, and pack away for emergency situations. Other primary research looked at experience teams went through for rescue and analysing existing food and heating products. From here, I focused the UTE and created a persona for a mountain rescue volunteer. I then made a specification to work from and compiled a rugged form board and a Land Rover inspiration board to give me design direction. Here, I've done some quick exploration of forms and basic functions. I then took these ideas to produce my first concept, a very basic reaction chamber based card modelled, functionality tested and evaluated by myself and peers. The main points of evaluation were the form was good, rugged, but it wasn't clear how the food heating process would work with little consideration of actually using chemicals safely. So from there I looked at alternative heating power sources, since preparing an exothermic reaction would be too fiddly for rescuers. I looked at battery power initially from the car battery to the charging ports, since rescuers are always with vehicles, but this would limit the range of the device. After more research, I settled on a 7.4 battery, which according to my calculations would heat a relative quantity of food to water in around 10 minutes and would be small enough to transport. I explored material choices for the main body of the product, settling on polypropylene due to its strength to weight ratio, toughness, price and chemical temperature resistance. I then started to further develop the form and components, looking at charging ports, lid designs and the food sachet, which, linking back to research, would provide pre-packaged, pre-prepared food, meaning no messing. Making the packet out of aluminium foil and a polypropylene mouthpiece and cap would allow for easy disposal via recycling. Also linking back to Land Rover's concern for environment and resources. I went on to look at portability, incorporating handles into the body. I decided on just having grips, since adding handles would either make the internal space too small for food and the technology or make the product too big. Speaking of internals, I looked at how the food sachet could be held inside the device, exploring metal surrounds to conduct heat. I thought suspending the sachet within the heating element by clips would allow for more efficient heat transfer. Looking at these heating element technologies, I decided on a nichrome heating element due to it being robust, relatively cheap to produce, and it forms a chromium oxide layer that would help protect the element from the elements. I also further developed the food sachet, adding a cap to protect the mouthpiece. From there I produced the second main product concept, with main developments being silicone rubber hand grips and a lid to protect the food sachet. Once again I tested a card model with points for development, including a larger consideration for transport, some kind of harness or belt attachment would be good, making it smaller as well as it was a bit cumbersome to use, and consider heating activation. The lid also got in the way, so I wanted to remove the need for the lid by clipping the food sachet into the product securely. Relating that back to the research, this would provide simple and quick use necessary for urgent situations. Since there'd be no lid, I looked at silicone rubber overmold flaps that the food sachet would be pushed through. They'd also help insulate the product and protect the interior whilst aiding in holding the sachet in place. Considering a charging port at the base of the device, I thought of a rubber plug necessary to protect the USB port. Focusing on transportation, I thought of adding a carabiner to the rear of the product, as it is a very durable, functional device, and going back to research would ease transportation. I went for a stainless steel mounting plate for its strength and corrosion resistance, and decided on riveting this to the back with aluminium rivets, since they're lightweight, strong, and don't take up a lot of room, unlike screws. I looked at button forms and front detailing, but decided the extra surface area would increase heat loss, so I decided to add the logo to the front. I looked at the form of the grip and detailing on it, and finalised more how the heating element would interact with the food sachet. Moving on to colour, a Land Rover green seemed like a very good idea, but that wouldn't be appropriate to a rescue scenario, so I went for yellow, which would stand out, and a contrast against the predominantly red rescue kit. I concluded black would be the best contrasting colour to identify interaction points. This brings us to the final concept, a durable and insulating 150 by 140 by 50 mm polypropylene case with silicone rubber overmolds for grips and flaps, featuring a clipping mechanism to securely hold the food sachet in place and easily release it. A securely mounted carabiner for transportation, and an underside USB charging port to power the 7.4 battery that heats the nichrome heating element to 40 degrees Celsius, so as not to heat the casualty too quickly to avoid further complications. It has strong Land Rover DNA and is compact and functional. Relating back to the specification, I believe I have achieved everything. However, the price may be in contention at £60 as affordable, but considering smaller production runs and relative to other kit, I think that it is reasonable considering its intended longevity. Here you can see how the components interact, allowing for a simple process which, relating back to research, is essential, since there would be less time messing with the device and more time dealing with the casualty. The overall basic form was influenced by the modern Land Rover steering wheels due to the bold form. Other components like buttons and grips were inspired by grills, surfaces, lights and other detailing. The general feel of the design comes from Land Rover Defender due to its iconic status and the rugged and bold forms. Evaluating ergonomics proved good, as the device had good proportions for hand interactions whilst maintaining its compact form. Buttons were easily accessible, but the carabiner proved a bit awkward to operate if you didn't get the right angle. Therefore, looking at areas of development, the carabiner would need a redesign, either being more custom, larger to get a better handle of it, or have an alternate transport solution altogether. As mentioned previously, price is an issue, so how could it be made cheaper with the same durability and functionality? However, overall, I think the design is very functional, rugged, good size for transportation and interaction, and would generally help the treatment of hypothermic casualties.